So hello everyone, welcome to our first video assignment of Introduction to Programming with Python. And in this video, we will go through two foundational concepts in Python. The first one is conditional and control flow, and the second thing is lists and sequences. So let's go on to the learning objectives of this video. So through this video, you'll be able to understand how Python makes decisions using if, else, and else. Apply control flow to make code respond dynamically to different conditions. And thirdly, create and manipulate lists and sequences to store and organize data effectively. And finally, we combine these two concepts together to develop interactive programs. So let's go through the outline. We just go through the introduction and overview. And the next thing we're going to do is learn about the conditional and control flow, including if, and else, along with nested statement and logic. After that, we will learn about lists and sequences with properties and operations, and we will also learn about how to really manipulate them in Python programming. And finally, we will combine both of the concepts together to see how they really work in practice, along with a summary and conclusion. So let's go to the conditional. So if you look at this picture right here, you will realize we do this every day, right? You see it's raining outside, you decide to bring an umbrella, and that's how conditional are in Python. The conditional let out program choices and run different code based on whether a program is true or false. So let's move on the if statement. The if statement is really simple. It's just only a word, if, and it is followed with a Boolean expression, and you have to really pay attention to this indentation right here. If there is an indentation, the Python programming will recognize that this code underneath here with the indentation belongs to the if statement. Otherwise, it will not recognize. So let's go to the control flow. We have one scenario here, which is conditional is true. So the program encounters the test expression and evaluates it. If the result is true, the program enters the body of if and then continue its execution to the statement just below if. So that's very simple. So let's move to the second scenario, which is false. The conditional is false. So this time, if the result is false, the program skips the entire body of if and jumps straight forward to the statement just below if. And that's all for the control flow. So here we will go to the Boolean expression. We have three types of Boolean expressions. The first one is Boolean variables, and the second one is Boolean comparisons, and the third one is Boolean operations and Boolean operations are. So here we come to the if-else statement. I will let our friend to take over of this part.
All right, thank you, Anne, for your presentation. So now we'll continue with our slide. As you can see, the if statement is great, but I find there's one problem with the if statement. If the condition is true, so it will still run the code. However, what about when it's false? So the if-else statement exists to solve this problem. If it's true, if the condition is true, so it will run this statement, but if it's false, it will run this statement. All right, so we'll move to the control flow. This one is different from the initial one. I'll divide it into two paths. For the first path, both of the paths will run through the text expression, and for the first part, it will run to the left to the body of if, and yeah, it will skip the body of else. And after that, it will go to the statement just below if. All right, so how about the false condition? As you expect, it will go to the right side and go through the body of else and go to a statement just below if. There's one notion that for the control flow of the if-else statement, it will just run only one of two things, the body of if and the body of else. It will never run both. And here is an example of the if-else statement. Yeah, will you marry me? I think this one is the very important question, especially for the men, right? And okay, I will have a question for you. If my input is yes, so what is the output? Okay, so as you expect, the output is yay. What about if my input is oh no, or no, I mean if my output is no or maybe? Yeah, the output is oh no. Okay, but as you know, our life is not as simple as we think. The if-else statement can only solve the problem with only 2 options. How about when we meet 3, 4, or even 5 options to choose? Yeah, the elif exists. The elif is just a shortened way to tell else if. Okay, and here's the format, as you can see. And okay, here's the control flow of the if, elif, and else statement. I love it because it just looks like a ladder or a waterfall. It's just based on your imagination. And the key of this control flow is just find the first 2 conditions to run the statement inside. If it cannot find any 2 conditions, it will go to the body of else. Okay. Next, we'll move to the example. Here's my BMI example. It's one of the most perfect example for the if, elif, and else statement. The user will input their height and their weight, and there's also the formula of BMI. Okay, I will ask you a question. If my BMI is 17, can you guess what is the output? Yeah, you're correct. The output is you are underweight. How about if my input is 22? Yeah, the print will print like you have a normal weight in here. Okay, let's move to the next if-else statement. I don't know if you guys know about this dolls, but I think if you have watched some Russian cartoons before, I think you may know about this. This is called Russian dolls. The Russian dolls is a kind of doll which consists many dolls with a different size. You can see the biggest one, and when you open the biggest one, there will be many small ones inside. And as you expect, the format of the next if-else statement is just like the same way with the Russian dolls. You cannot meet the inner Boolean expression if the condition of the outer Boolean expression is not true. Okay, and here's the control flow. Yeah, I think it's very simple, and it's just like the other control flow that I have already shown you. So I will skip this one. And here's the example of the next if-else statement. I think this one is very common, right? We have like the username and the password. Okay, one more question. If my username is Jacob, you think what is the output? The output is username not found. However, if my input is admin, but my password is 3456, yeah, it will run like password is incorrect. Okay. So I'll show you some common mistake of the if, elif, and else statement in here. There are 3 mistakes. I'll give you some minute to define which one is a mistake in here. Okay, all right. There are 3 mistakes for each image. For the first one, there are 2 mistakes that we often find. The first one is miss a colon, and for the next line, it just filled the indentation error. For the second image, it just have a mistake to, I mean, in here, it must be the comparison value instead of the assignment one. And for the final one, this one is one of the tricky errors that many one always met, but they cannot define it. Okay, so this one called the logical error. If we code like this, so the LF line cannot be met, although it still meets the requirement. Okay, I finished my presentation here, and I will give to the next one. Thank you.
Okay, thank you, Tuấn Minh, and now we'll move on to the next part, which is about lists and sequences. So these are the topics that we will be learning in week 6, and today we'll focus on lists and how they work and how do you use them. So let's think of a real-life analogy first. This is a standard to-do list. It's my to-do list, actually. It contains the tasks that I have to do in a day. So I can do anything I want to do with this list. For example, if I've done a task, I can cross it out, which is only sleeping. If I forgot a task that I should have added, I can add that task now. And even I can give my list to another people, and I can have them copy to make it their own. So think of lists in Python the same way, but some key differences. So first, let's talk about the data type of list. So list is actually sequence type in Python, along with strings and tuples. What is sequence types actually? Sequence types is a data type that the program can iterate over. So that means that lists or strings or tuples must have smaller elements with indexes that the program can actually go over one by one. And according to Python's official document, lists are also referred to as a compound data type. What is a compound data type? I will show you the reason later. But now let's look at Python syntax or format. It's actually very simple. Declaring a list is very much like declaring a standard variable in Python. You will have the name of the list, and you will have the content or the value of the list. You can actually see that the elements in this list is separated by commas, and they're all surrounded by a pair of square brackets. And just like strings, they're ordered with index from 0 to 2. In this case, because there are 3 elements. So because strings and lists are both sequences, so everything we can do with strings, we can also do with lists. Things like manipulating or having splices with indexes. Just to demonstrate, I have a very simple piece of code here. You can pause the video and guess the result, but I'm not going to wait for you, and I'm just going to show you the result here. First, a second line of output, a third line of output. It's very simple. However, this is the big question. If lists and strings are both sequences and they're so similar, are there any big differences? Well, actually there are, and we know from other lectures that strings are immutable, meaning that they cannot be changed. The reason for this is that we don't want the program to accidentally change our string values. But it's a different story with lists. With lists, we actually want it to be more dynamic, to be able to adapt and update to the values that the program change to the list. So lists are actually mutable. And I have another piece of code here that I will show you. I'm not going anywhere. I'm just going to my computer. So as you can see here, I have a list of 3 number, and I want to change the first element to 0. And when I run it, the first element of the list was actually changed from 1 to 0. So it is mutable. But what if I want to change the element with index 3 to 4? So actually, the list has only 3 elements, but I want to change the 4th element to 4. So this will result in an index error. So why is this? You can figure it out at home, but It's interesting because what I did is that I tried to add another number to the list, but it doesn't work. So we have a big question: can lists actually change their size? And I'm go ahead and answer to you: yes, they can, but you have to use specific method, which Tâm will show you later. Okay, now we will go to list objects, and specifically the reason why lists are mutable. So as you can see here, the whole list is actually a reference to a list object, and the elements inside, they are not objects themselves, but they're just reference to each object. So this structure is actually ingenious because just like if you want to change a string variable, you have to create a new string object and refer that variable to the new string object. However, for lists, you don't need to do that. You just need to change the reference from one object to another. For example, here I want to change the first element in linear algebra to something like intro to law. I don't have to create a new list object, but instead I just need to change the reference from object one to another object. So list-based, its operation, its memory use a lot on reference, and the same goes with how it adds new space and get rid of old ones. So if you run out of space, let's call this each of this square a space. If you run out of space on a list, it actually go ahead and pre-allocate more space so that new reference can find their place easily. And the same goes for freeing up a space. If a space doesn't have any references in it, Python will just go ahead and free up that space. So it's very efficient. With all that advantages, actually this being dynamic for lists cause some problem for programmers. Suppose that, okay, I will go back to my demo code. Suppose that I have two lists. So what will happen is that because when we change a value of an element in a list, it doesn't create a new list. So theoretically, two variables of two different names can refer to the same list object. So everything that happened to one list will happen to another list. So if I run this, and you can see that both list 1 and list 2 experience the change. This is because, as I said, both of them refer to one list object. Okay, so remember that I told you lists are compound data type. This is because each of these elements can refer to any data type: strings, floats, integers, and even other lists. So if a list is an element in another list, it's called a nested list. So the way you access nested list is very simple. It's just like normal. First you access the element of the outer list, which is the nested list, and then you use another index to access the elements inside that nested list. And we actually have a really cool application, is that we can represent matrices using nested lists, such as a 3x3 matrix that I'm having here. Okay, so before we wrap up, I want to make sure that you understand how to differentiate between a string and list. So just remember that the only similarities between them are that both of them are sequences, and they can access their elements using index. The rest are all different. You can pause here if you want to read the table. But now I will leave the stage for Tâm to talk more about the methods of lists.
So thank you, Hiền, for the useful definitions about lists and aliasing. So next, moving to the next thing is modifying lists. So right here we can see that the most important properties of lists is that they are mutable, and this simply means that we can change the add, removes elements easily after the list has been created. So you can see the example code block right here. So we have a list of fruits right here, and to replace an item in the list, you can use the method that dot append. You can use the method that with the fruits 1 equals mango to replace banana in the list right here. And the dot append and insert is as two different methods to add more item into the list. that the dot append is you can add the values into the every end of the list. And the next thing is the insert. You know, it's the more specific way that you know you want to add the item in the elements in the position or specific index in the list. And the last output is the result showing right here is after the modifications. So the next thing is the removing elements. The removing elements, there's many ways that you can remove. If you know the values, you want to remove the values, you can use the dot remove. And the next method is the dot pop. If you want to remove a specific position and index, you use the pop 2. That means you remove the index at number 2. And the next thing is the clear. You clear the empty, the list, and the final output is empty. Next thing, these are the useful list methods I have mentioned right here, and right my hand side is the example right here. And I have mentioned around like 5 of them, and just a few more news for you. It's very useful for every programmer when doing list or modifying list. And right here you can see the attend. The attend methods is for adding R item from the another list. Now you have a different list. You want to add the list to the currently list. You can use the extend method. Next is the sort and reverse. The sort is to sort the list in ascending order, and the reverse is just make the orders of the elements. And the third thing is the combining and repeating list. So we can use operator to combine or repeat itself, repeat list. Like right here, we have an example of a list like A and B list. We can combine it by using the plus operator, or repeat it by using the asterisk operator. And it's just a simple way, and I think that this is a useful way to combine and repeat the list, and it still hold the original list, and they are not changed. The next thing is the building function. The building function is useful for data analyzing or for statistics. And also, you know that Python has built-in functions that makes list operator easier. Right here we have a number list of number. We can bring the length number right here to observe the length of the values in the list. We can use some marks mean to analyzing more easily. And right here we can have the short. Short is different more than short that I have mentioned before. The shorted here doesn't change the original list after all, but the short has changed the list after we print the final values, final output. So maybe the next thing is copying and analyzing. And as Hiền mentioned before, he mentioned, he defined very well about the analyzing. I just mentioned more about it, the difference between it. Right here, when you assign one list to other, it doesn't make a new copy. And they both share a memory. Right here, we have a list A, and we do the B equals. So the B, when you try to add more item or update the list B, it also affects the list A too. So I have mentioned more about the resolutions, how to fix this. That there's 3 options for you to fix this problem. And as you can see right here, I recommend you guys do the first method because it's more clearly and it's also easy to see when you build up your code. So thank you for listening. My part is next to Đăng Minh will tell you guys more about loop in Python.
Before we move into the next section, we need to understand an important part of combining control flow and sequence, which is using loop in Python. So a for loop in Python is used for iterating over a sequence such as a list, a tuple, a dictionary, a set or string, but we will mainly focus on lists. With the for loop, we can execute a set of statements, one for each item in a list. To use loop, we first need to create a list and then start with for. We can see in the example here, we have a list called fruits, which includes some fruits in here. So for x in fruit, which means the program will loop through each part in the list, and then print x will print each part of the list. So here are some statements when using loop, such as the break statement, which is used to stop the loop before it has looped through all the items. The continue statement, which is used to stop the current iteration of the loop and continue with the next. And the final one is the range function, which used to return a sequence of numbers starting from 0 by default and increments by 1. And now we will move to the main part, which is combining control flow and sequences. The first use of combining control flow and sequences is used to select specific data that meets certain conditions. Here we have a list of numbers. So as you can see here, we are choosing the positive number from this list. So can you guess the output? You can pause. So the output here is yes, the positive number in the list. And this example used a for loop in the control flow with list iteration and an if condition here. So the next use of combining control flow and sequence is find or count item in a sequence that meet a condition. For example, we see a list of name here, and then we will count how many names start with A. And as you can see, the result is here. And this example combines a for loop in the control flow with list iteration and an if condition, just like the previous one. Okay, so the next use is to build lists, dictionary, or sets dynamically, which is used to build a new set or new list from a previous list. Here we have an example of the numbers from 1 to 5, and then we create a new list here, which is the square of each number in the original list. So this example also combines a for loop with list comprehension. List comprehension is that when you perform action in the list. Okay, the next example is to perform decision-based task. Also, this example used to grading each student. So if the student grade is more than 80, it will print excellent. If it is more than 60, then it will print pass, and else it will print fail. So this example combines the list sequence and else if and else statement. And the final one is we use nested loop and condition to handle structure or hierarchical data. So example here is that we have a matrix, and we will find the even number in this matrix. And this use the this example use nested for with a list sequence. So why do we need to combining control flow and sequence? So first, it will make your code more flexible and avoid repetitive code. And it will also help you to modify each item in the sequence easier. And it will also help you searching items in a sequence and filtering data in a sequence. So, so through this lesson, you have learned about first is how Python makes decisions using if, else, and else if statements, and you also understand how the control flow work and use them to make code respond to different conditions. And you also learn about the basics and properties of list and sequence, and you also know how to create and manipulate list and sequence. And you have also learned how to combine control flow and sequence and its use. So thank you for listening. So that's all of our content.